We're now going to introduce what we call the Z-transform. We're very used to working in the transform domain. When working with continuous time signals, we talk about the Fourier transform and the Fourier series. When working with discrete time signals, we've talked about the discrete time Fourier transform and the discrete time Fourier series. We now introduce a new transform for discrete time signals that we call the Z-transform. In many ways, the Z-transform is the discrete time counterpart to the Laplace transform. If you remember, the Laplace transform is a transform that takes you from the time domain to the S domain. And the Laplace transform is useful when dealing with signals that you can't work with the Fourier transform with. So there are some limitations when you try to take the Fourier transform of a signal that you run into problems mathematically, things don't converge, they blow up, and you can overcome those difficulties, those convergence problems with the Laplace transform. The same type of thing happens here with the Z-transform. There are certain signals that we can't take the discrete time Fourier transform of because there are convergence problems, but we're going to overcome those problems with the Z-transform. The Z-transform has an extra kind of parameter that we can control to control the convergence of the math that we're about to do. So just like the Laplace transform was a more general transform, and in it the Fourier transform you can get it. Same thing happens here. The Z-transform is a more general transform, and out of it you can actually get the discrete time Fourier transform. So the Z-transform is actually a more general transform, and as a special case you can get the DT. So here's the definition. The Z-transform representation, so this is how we can take a time domain discrete time signal into the Z domain. The bilateral Z-transform of the discrete time signal x of k is defined right here. So this looks just like our definition or quantity that we saw earlier called h of z, which was the sum from k equals minus infinity to infinity of h of k, z to the minus k. So that work that we previously did was basically what told us how to define the Z-transform. Notice this is called the bilateral Z-transform. The bilateral Z-transform sums from time minus infinity to infinity. We'll talk about something later called the unilateral Z-transform that starts at time 0 and goes to infinity. But typically if we say Z-transform, what we mean is this bilateral Z-transform quantity. This equation is how we go from the Z domain back to the time domain. If you give me x of z, theoretically I can plug into this integral right here and get out x of k. Now one thing you'll notice is this integral looks kind of funny. It's not a typical integral symbol. This is an integral with a circle right here. So that's something most undergraduates have not seen. This is what's called